with the third installment of World's Longest Review Sheet. Let's see here. Where am I? Give an example of the following graphs. Note the scales are by 2. Give an equation. Okay. So this is an absolute value graph, so I know that's my container, but I do see that it goes up 1, 2, 3 over 1. So my function is going to be 3. It's not shifted around at all. That's the only change. So it's going to be 3 times the absolute value of x. Here, let's see. It's an x squared graph, but it's shifted. It looks like, oh, it says the scales by 2. Shoot, that makes this. I didn't see that. It says scales are by 2s. So that would make this a 6. No, that would still be 3 because it'd be up 6 over 2. So, JK on that. Okay, how about here? If this, why is the scale by 2? Why do we have to do that? So if this is 2, then this has been shifted 1 to the right and 2 up. But it's upside down too. So I have that negative out in front. So my function has to be flipped over. It's average size, so I'll leave it at that. But then it has, since it's gone 1 to the right, I'll have a negative 1 inside the container, but then it goes 2 up, so I'm going to have that plus 2 to move it over. Okay, so here, I'm sitting here just kind of stewing about this scale, the whole 2 points thing, sorry. This is a cube graph, except it's coming down from left to right, so it's going to be negative. And it's also shifted up 1 because the scale's by 2 for some silly reason. So f of x is going to be a negative x cubed and then up 1. This is a square root. I can tell by the shape. It is flipped around, but it's flipped around the y, if you can see that, because it's supposed to be heading off that direction normally, and it's actually going that direction. So flipped around the y means there's going to be a negative x inside here. It's also shifted up 2, so I'll have a plus 2 over here. But it's also shifted 4, because we're counting by 2s, to the right, which is going to look like this. Okie doke. Here I am using the graph, so I need the graph values, top function f, bottom function g. This is asking for f of 2 plus f of g. So I just find those values. F at 2 is going to be this point, so 1, 2, 3, 4, 5. And then I'm going to be adding g of 2, so at 2 that's 2. So I get a 7. Subtraction is simply g of 5 minus f of 5. So at 1, 2, 3, 4, 5, the f value is a 2, and the g value is a negative 2. And so I'm going to have 2 minus negative 2, so I end up with a 4. Actually, I did them backwards because I'm not sure why. So g is going to be my negative 2 and then minus the positive 2, because I just don't know why. So let me just go back to that because I probably confused you. So what I wrote down here is correct. It goes g minus f, so these values, and then I just put them in the backwards order. So the g value is the negative 2 minus the positive 2 lands me at negative 4 because math is hard. These two crammed up against one another means to multiply the f of 2 value times the g of 2 value. So I'm going to multiply those. When I look up f of 2, I'm at 1, 2, 3, 4, 5. And when I look up my g of 2, I'm at 2, so the product is 10. This is a composite. This would be the same as writing f of g of 5. Get those two notations kind of into your brain. So this means I need to find the g of 5 value. So if I go 1, 2, 3, 4, 5, g of 5 is negative 2. So I'll be finding f of negative 2. I go to negative 2. I find my f value. It is at positive 2. Here I'm starting with f of 2. So at 2, I'm at 1, 2, 3, 4, 5 for f. Now I'm plugging that into g. And if I go to 1, 2, 3, 4, 5 at g, I go down 2 to hit the graph. They really used the same points the whole entire time. So much waste. So this one's using your calculator. So in the interest of time, this is like pre-graphed. And the points that are important here, and I'm not going to have very much room, I'm going to kind of just go zoom, zoom and draw my graph. And it's going to go here. I had it kind of here, and then I went to like up here-ish. And then I ended up with my min kind of here-ish. So the sketch is not super important, except it gives me what I want to look at. This is going to be a 0 value, this is going to be a max value, and this is going to be a min value. So I find those a variety of ways. By finding second trace max, I really care about my x coordinates for that. And so my x coordinate, hang on one second, I'm going to grab something. I wrote these down and I don't want to regraph it while you guys wait. So my max value is going to have an x coordinate of negative 0.816 according to my calculator. And if you're graphing it properly, you should get the exact same thing. My minimum value occurs at positive 0.816, and that 0 or x-intercept value I have occurring at negative 1.769. And I'm only writing down the x's because that's all I need because I'm doing interval notation. So when is it increasing? It is increasing here and here. So that is going to be from my negative infinity, meaning all the way at the left end, until it hits that max at negative 0.816. It is also increasing from the minimum, which occurs at positive 0.816, and then forever to the right. Where is it decreasing? It's decreasing here. Where is that? That's from my max, which occurs at negative 0.816, to my min, which is at positive 0.816. When is it positive? So positive is up here, negative is down here, right on the middle line at the x-axis is 0. So it's positive, meaning above the line from this 0 on. And the 0 occurs at negative 1.769, and then it goes forever to infinity. And the negative 1.769 isn't included because at that spot, the graph is 0, not positive. How about negative, meaning below the graph? Well, the only part below the graph is this section, and that's from negative infinity until I hit that 0. Again, not included. Evaluating f of pi simply means that I'm going to put in pi for all of the x's. So I'm going to have a pi cubed minus, and we are in big kid math, so we go ahead and use the pi button so that we're not just using 3.14, and you should get 26.723 because it does say 3 decimals. The test will say 3 decimals, so use 3 decimals. The last one is asking where it's going to intersect at this y value. So that's the one that most people got wrong on the test, or quiz, I should say. I'm going to get rid of all this other mess on here for now. Oopsies, I actually erased my graph. That was kind of dumb. So let me re-sketch that. Zoom, zoom, zoom. Okay, so it's asking where is this going to hit negative 1? So I'm going to go to my calculator, leaving in the first graph and typing this in as the second, and then I can see that there's a point where they will cross. So I use my second trace intersect to find that value, and it occurs at where x is negative 1.893. That's going to be the value where those two intersect. And then here, this one's asking you to plug in a negative 3, in which case you get D. And this one is asking sort of more of a conceptual question, but you do get a negative 1. There are not ACT questions on your chapter test. It's just the concepts. Okay, that's the grand finale. Now you know everything. Ace that thing. Bye.